Hello again, and welcome to the second session of this topic, which is DC machines. So we shall start from motor starting methods. That is where we will start for today. We'll look at the two major categories of motor starting methods, which are the single phase and the three phase motor starting methods. So those are the two broad categories of the different ways in which a motor can be started. So we shall start with a single phase motor, and in single phase motors we always say that they require often a very special starting methods because of their inability to start on their own. That is, they have to have something that can trigger it to give it that starting torque, which is like a greater strength that can enable the motor to start fast. Then after it has undergone some series of revolutions and attained a certain percentage, then that is when now the secondary part comes to maintain the revolutions and also the speed. So we have different ways in which a single phase motor can be started. One way being the split phase start, whereby if you look at that circuit, it has the main winding, a start winding, and it has a centrifugal fuse. So this one, when you're explaining, you just say that it uses an auxiliary winding and a capacitor that is used to create a phase shift, that is enabling the motor to start. And it also comprises of a main winding that is often of low resistance and a high inductance value. Then it also have an auxiliary winding that is of high inductance and low, that is of high resistance and low inductance, sorry. So in terms of operation is when the supply is connected, the different resistance or reactance ratios of the two windings, they'll have to create a phase difference between the currents, and this phase difference is the one that will produce a rotating magnetic field that will enable the motor or initiate the motor to start. So as the motor starts, it has to go for some time due to a series of revolutions. After it has attained between 70 to 80% of the synchronous speed or the maximum speed, then there is this centrifugal switch. It will disconnect, allowing the motor now to run on the auxiliary winding. So that is how you explain a split phase motor starting method as a single phase motor starting method to be used. So it does not have a very complicated circuit, but it's just basic. So that is one step. Its application, it can be used in small fans, blowers, washing machine, and lathe machines. And then we have another single phase motor starting method, which is a capacitor start. As for the capacitor start, you can see the circuit there. We have the rotor, we have capacitors, we have a switch, we have the main winding, we have the auxiliary winding, and we have the phase supply. So this method also, it involves a capacitor that is in series with a start winding. So that capacitor, it is the one that it's necessary for providing that high starting torque or that high starting momentum in order to allow the motor to start rotating. So when you're talking about its principle of operation, it's just similar to that split phase, but instead of relying on the windings of the resistance, that capacitor is connected in series with the auxiliary winding in order to create now a slightly larger phase shift. So when the capacitor causes the current in the auxiliary winding to lead, that is having a positive value, then the main winding by about 80 to 90% degree phase shift, because from the previous circuit we were talking about 25 to 30% phase shift. Now the capacitor, when it's included and it is in series with the auxiliary or the primary winding, then the phase shift is increased to about 80 to 90 degree. So that will be essentially possible in producing high or a strong static torque that will now initiate the motor to start rotating. Then once the motor reaches about 75% of its synchronous speed, there is that centrifugal switch that will disconnect or opens, thus disconnecting the capacitor and allowing the auxiliary winding, thus allowing the motor to run on the main winding only. So if you look at those explanations, we are just talking over what initiates the starting torque or what makes the motor to start rotating, and what necessitates the motor to now continue rotating, which now brings to you that you have to know the components that are taking part in a certain motor starting method, be it a single phase or a three phase. So we have advantages that it has a high starting torque that is at least 3 to 4 times that of the split phase. Then it is smooth and reliable starting. Application can be used in compressors, pumps, refrigerators, small machines, etc. We come to the third method, which is the capacitor start, capacitor run method. So in this method, you've seen there are two circuits that are connected in parallel. So it means that for the capacitor start, capacitor run, it uses a starting capacitor and a running capacitor so as to improve both the starting and running performance of the motor. So that static capacitor, it is usually made up of an electrolytic type, and it has a high capacitance that can enable the motor to start. Then you have a run capacitor that is of low capacitance, and its main aim is just to maintain the continuous operation of the motor. So when you're explaining, you say that both capacitors are connected in parallel. My cue, I know by now, every one of us knows how to differentiate between a series connection and a parallel connection of a circuit based on the topic 2 that we learned about DC and AC circuits, and there's so many calculations we did on the same. So when the both capacitors which are connected in parallel with auxiliary windings during static, the large start capacitor is the one that will provide that high phase shift and a strong starting torque. So after providing that, it is when now the motor will start to rotate and gaining momentum slowly by slowly so that it can reach that 75% of the synchronous speed, and that's where we term that motor to be stable, or that system to be stable. So that centrifugal switch will disconnect the start capacitor, leaving the motor to entirely now run on the run capacitor and initiate or till completion of a task. So the power continues to operate as a two-phase motor, improving efficiency and power factor. You shall come down to know what happens in power factor when you're talking about rectification. So we have advantages. So one advantage is it's very high starting torque, it's quiet and efficient, improved power factor, and so on. Applications, it can be used in air compressors, heavy duty pumps, high efficiency fans, and so on. Then we also have another method, which is the resistance start. So the resistance start says that it employs resistors in the start winding in order to create a rotating magnetic field for starting that is suitable for small motors. We can look at the circuit also. It has a main winding, a centrifugal switch, an auxiliary winding, and also a rotor. So when you're talking about the principle of operation or the physical design, we just always say that when you're talking about the physical description of a circuit or the design, we just look at how are the components connected, whereby if you look at that circuit, the start winding is connected in series with a variable resistor, and this limits the current and adjusts the phase difference between the two windings. So when you're talking about operation, is that the resistor increases the resistor in the auxiliary circuit, thus causing a phase shift between the main and the start winding currents. So this phase difference is the one that produces a rotating magnetic field, enabling the motor to start. And after the motor picks up the speed, the resistor, that is often the auxiliary winding, is disconnected. So its advantages is that it's simple, inexpensive, it has a moderate starting torque, and its disadvantage is its low efficiency, poor torque compared to capacitor motors. Then we have the final single phase motor starting method, which is a shaded pole start. So this one uses a shaded pole arrangement that is used to create a rotating magnetic field for starting, suitable for small motors. If you look at how the connection is, the main winding, we have the shading coil, we have the stator, we have the main pole, and also we have the phase AC supply. So when you're talking about the principle of operation, it's just that it's divided into two parts: the shaded part that is always surrounded by a copper shading, and you have the unshaded part. So it means that when you're talking about operation, when the AC flows through the stator windings, there will be that change in magnetic flux which will induce a current in the shading coil. And my cue, you have to remember that when you're talking about current being induced, it always acts in the opposite direction of flux. So this current will create that lagging magnetic effect in the shaded portion, and the flux will shift from the unshaded part to the shaded part, thus producing a weak rotating magnetic field. So this field will give the motor a small starting torque that is enough to start the motor in one direction. So the advantages are it's very simple and rugged. No centrifugal switch or starting capacitor is needed. The disadvantages is it's very low starting torque and efficiency that is suitable for small loads. Applications like table fans, hair dryers, small blowers, electric clocks, and so on. So those are the methods for starting motors, that is in single phase motor starting methods. You have looked at some common terms that are appearing there. What initiates the starting torque, what maintains the rotation, and also once the motor reaches between 75%, that is 70 to 80%, if it's within that range, then that machine is considered to be stable. So when you're giving that description, always master the circuit, master the components, master on how are the components linked together and how do they communicate. Then it will be very easy for you to give the description of any circuit that you are asked in any setting. So we go to the three-phase motor starting methods. So due to that inherent instability of for you to start a motor for a single phase motor, it always required for you to have that high starting torque, which essentially could draw a lot of current. So there came a need where we had to introduce a three-phase motor starting method that will eliminate that starting torque that draws a lot of current and makes use in such a way that the motor can start smoothly and run smoothly at the same time. So that's why there was a need to introduce now the different ways of a motor starting method, which is a three-phase, and it's very quiet and reliable. So from that introduction, The three-phase motors generally have a more straightforward starting method as compared to single phase, and the common methods are direct or line. So direct or line, it means that the motor is directly connected to the power supply that is providing full voltage and current, and it's simple but may cause high starting current at some point. So the principle of operation, if you look at that diagram, we have a three-phase supply, that is a blue phase, a yellow phase, and a red phase. It is being passed through a fuse or a circuit breaker. The main aim of a circuit breaker is just to connect or disconnect a circuit in case there is an overcurrent. Then it passes through a normally closed contactor. We have an overload protection that protects again the circuit from overcurrent that is being fed to a three-phase motor. So we are talking about the principle and operation. This type of three-phase motor starting is the simplest and the most commonly used for starting three-phase motors, three-phase induction motors. So in this one, the motor is always connected directly to a full supply voltage, or what we term as a full phase voltage. Essentially, it's usually between 400 to 415 volts through a magnetic contactor. Then in order to start that motor, we always push or press the start button. The motor will be able to receive the full line voltage, and it will immediately begin to rotate and develop its full starting torque. However, there is a high starting current that is always usually 5 to 8 times of the full load current, and that's why there is that thermal overload relay provided in order to protect that motor from excessive current. So when the stop button is pressed, the contactor will open, thus disconnecting the supply because of its simplicity and cost. So the direct online starter is used for small motors, usually below 5 horsepower, where the high starting current does not cause serious voltage fluctuations. So that is essentially the principle of operation of this circuit, and if you look at it clearly, it's well explanatory. You have just to know the sequence of how the each component flows. And here we are talking about a three-phase supply. We're talking about a phase that each phase is supplying current, so there is no neutral line here. So that is one method. We have another method that is called the star delta. The star delta, it means that initially, so for the star delta, it means that the motor is connected in two ways. That is, initially the motor is connected in star for reduced voltage and current, and then during startup, when it's being starting, now when you're starting, it's connected in star. But now, in order to maintain that full voltage continuation or the rotation, the motor will now switch to delta. So it's like a connection of two sets: the star for starting, the delta for maintaining the operations or rotations. So we have the power circuit diagram for a star, and also here we are feeding the motor with a star connection. If you look at that, we have three phases: phase 1, phase 2, and phase 3, passing through an MCCB, three-phase MCCB. There's also a contactor, which is the main contactor. It passes through an overload relay to power the three-phase motor. And there is also the delta side, where the delta side you'll have to look at how the connection is made in the delta side. It is not the same as how the connection is made in the star side. So when you're talking about the principle of operation, is that this method is used for motors that operate normally in delta connections, but are usually initiated by a star configuration, such that it is assumed that when the motor is connected in star, then each phase will receive only 58%, that is a third of the line voltage. So this results in a starting current that is always 1/3 of what it could be for a direct online start. That is, when the motor could be powered directly. And then consequently that starting torque is also reduced to about 1/3. So the motor starts in star connection and it accelerates with reduced voltage and current to an approximate 75 to 80% of its rated speed or its synchronous speed. There is an automatic or a manual timer that changes the winding configuration from star to delta. So in this delta configuration is when the motor windings will receive the full line voltage, and now the motor will be able to deliver its full torque and power under the normal operation. So you can be asked about the applications of such. You can just say that they are used in medium-sized motors where the reduced starting current is required, but the load torque is not too high. We also have another method which is an autotransformer starting, whereby it uses an autotransformer to reduce the voltage applied to the motor during startup, which limits the inrush current and reduces mechanical stress. So there's a circuit diagram here for an autotransformer. It is also having a three-phase supply system. We have the start and running components, and you also have the autotransformer. So when you're talking about its principal operation, we say that this method, it uses an autotransformer to reduce the voltage applied to the motor during starting. And remember that an autotransformer has several tap settings, and the common ones we have are 50, 65, and 80% of the line voltage. So this allows for flexibility depending on the starting torque that you need to drive a particular load. So when you press that starting button, the motor is connected to reduced voltage supply from the autotransformer, which will lower the starting current and torque proportionally to the voltage ratio. So as the motor accelerates and it approaches about 75% to 80% of its rated speed, a changeover mechanism disconnects the autotransformer and connects the motor directly to the full line voltage, and this method provides a smooth acceleration and a better control of the starting current as compared to a star delta. It is commonly used for large motors above 20 horsepower, such as in compressors, powers, and conveyor. So we have another method which is a soft starter, whereby gradually it increases the voltage supplied to the motor, allowing for smooth acceleration and reduced starting current. From the circuit, you can be able to view the circuit also. It's also being powered by a three-phase system. That is, it means that we are powering all the phases are live, they are transferring current. So this principle of a soft starter is that it's an electronic starting device that gradually increases the voltage supplied to the motor during startup. That's just to ensure that there is a smooth acceleration without mechanical shock or electric surges. So it uses a solid state device such as a thyristor or a silicon controlled rectifier (SCR) or a triac. We shall come to know more in electronics. We'll be dealing with the other topic more about a thyristor, an SCR, and a triac arranged in a phase to control the voltage by adjusting the firing angle. So initially, the voltage that is applied to the motor is always low, which limits the inrush current. So as the motor starts to accelerate, the soft starter progressively increases the voltage until it reaches the rated supply level, allowing the motor to attain a full speed smoothly. So many soft starters, they always provide a soft stop function, reducing voltage gradually during deceleration. So the acceleration time, starting current, and the torque can all be programmed for a specific application. The soft starters are commonly used in pumps, conveyors, HVAC systems, where smooth starting and stopping are essential. Then we come to the final three-phase motor starting method, which is a variable frequency drive. And in our syllabus, we mentioned about special machines. So the soft starter and the variable frequency drive, they fall under a special machine. So the variable frequency drive, it controls the motor speed by starting characteristics by varying the frequency and voltage supplied to the motor. So from the word variable frequency drive, we are talking about a variation in frequency and voltage. The principle of operation is that it's an advanced electronic controller that regulates both the voltage and frequency that is applied to the motor. And with this, it allows for the precise control over speed and torque. So the conversion first is that the incoming AC power, it's turned to a DC, and that conversion is achieved by a rectifier circuit. A rectifier circuit can comprise of a diode, because if a diode is inside a circuit, then they are responsible for rectifying the voltage. Remember, we are converting that to a DC because the DC is stable. It's stable. So this DC voltage is then inverted back to AC with a variable frequency and voltage using an inverter circuit. So composed of insulating gate, bipolar transistors or similar semiconductor devices. So during startup, the VFD begins with a low frequency and a low voltage, resulting in a gentle increase in the motor speed with minimal inrush current as the frequency and voltage rises proportionally, maintaining a constant V over F ratio, that is a voltage over frequency ratio. So the motor will accelerate smoothly to its desired operating speed. Then the VFD itself will allow not only for a soft starting but also a variable frequency control in terms of energy savings and torque optimization throughout the operation. So this method is ideal for applications such as conveyors, pumps, fans, compressors, and elevators, where speed regulations and energy efficiency are required. So those are the three-phase motor starting methods that you're supposed to know. So the main aim is just to master the circuit. How are the components connected? What are the components that make up that circuit? Because if you're able to understand the components of that circuit, then you can be able to explain the circuit. If you master the circuit, also how to draw the circuit, how are each connections done from the line through the fuse, through the contactors, through the overload relay, and now powering the motor, you can be able to explain in details of the connection. These questions for this type come in two sets. One, it can come in a way that you can be told to describe with the aid of a diagram, describe the operation of a certain method of a motor starting method. You can also be told to describe, to list any applications of a certain type of method, and you can also be told to list, maybe in section A, list any 4 motor starting methods, single phase motor starting method. It can be subject specific, or it can be a general question. You can just be asked to list any 4 motor starting methods. So you always master that in single phase we have the resistance start, capacitor start, and capacitor run, the split phase, and we have the shaded pole. And for 3-phase motor starting methods, we have the direct online, we have the star delta, we have the soft starter, we have the auto transformers, and finally we have the variable frequency drive. So if you can be able to differentiate that, then you're good to go. Otherwise, we shall have another session where we shall now talk over the generators. Also, we shall talk over the characteristics of generators, each having a different characteristics, and we shall also do the calculations that are involved in generators and motors. So have some great time.